Alright, so now in this video we have a setup that I would actually use if I wanted to recharge a solar generator with a USB power bank. So I have a number of these USB power bank, not a ton, but a few more than this. And I fried one though a bit ago. But in any case, we have them connected in series. There you can see we got 17.1 volts coming out of here. These two power banks, the black of that one, alligator clip, is connected to the red alligator clip of that one. And so that makes them in series. They're connected together, and then the negative of this one goes there, positive of that one goes there. So since they're both outputting 5 volts, but they're connected in series, we have a total of about 10 volts right there. So it's a little bit lower because it's providing power. So that's what's coming in, and that's what's coming out. I set it to 17 volts. I have the resistors here. The stuff here, when I just had one power bank in this booster, doesn't matter with the two of them as well. Once I get above about 12.7 volts, current starts basically flowing freely into the unit. The unit will accept more than one or the two power banks can provide. And so I think they just think there's a short circuit and they shut down. Everything shuts down, that stops charging. So I have a couple resistors here. We raise up the voltage, and that limits current, and so the power banks can tell there's a load. So we could use lower value. There's all kinds of ways we can modify this. But in any case, that's what those resistors are doing. And then that's just barrel plugs. I'm doing barrel plugs to barrel plugs along the way. And so the negative for it, there's just a black wire going from the negative of one to the negative of the other. The resistors are going from the positive of one to the positive of the other right there. So I set it to 10 watts for a reason. These have to provide, there are a little bit of power losses, but for the most part, out of that 10 watts, since these are in series, these power sources, they're sharing that wattage. So 5 of the volts is from one, 5 of the volts is from the other. They both have to pass the same current though. And so since each one of them is providing half the voltage while they're in series, that means that they are sharing the power equally, half the power. Now with the resistors, they're both 10 ohm resistors right there, and they're 10 watt resistors. So that's why I set it to 10 watts as well. That's because whatever power is coming through them, since they're equal value resistors in parallel, one of them has to dissipate half the power, and the other one has to dissipate the other half of the power. So I may have things a little bit wrong, but I think they're dissipating a total of about 10 watts. So probably each one of them is dissipating 5 watts. That's stuff we could test out later. Maybe they're actually dissipating more wattage than I think. Maybe we're wasting a lot of wattage, and that's just the wattage that the unit's getting. So those would be good things to test, but we're not going to worry about that right now. We're actually charging this with the USB power banks, which was the goal for this video. So right here we have the barrel jack there for the barrel plug. It is the 5.5 millimeter by 2.1 millimeter plug, the probably the most common one, probably by far. I don't know, it's by far the most common one I have. So as I said before, these are 10 ohm resistors. They're 10 watt resistors. So if we got 10 watts of power going, we really don't want more than 5 watts through one and more than 5 watts through the other one. So I think we accomplished that. And so these are just screw down right there. And you can see I got the resistors going to the positive there. And then the negative, we have the jumper wire. And we come over here. So this is the way it goes. The center is positive right there. And the ground, or the negative, is the outer body right there. And so this one is a female one still. That is the positive inside, and this metal part is the negative. You can see it wired there. There are guitar pedals where they have the opposite polarity. I don't have any guitar pedals, but in any case, every once in a while you might have something where the polarities need to be opposite, but this is the usual wiring for that. So in any case, they are in parallel. They'll share the current since they're equal value resistors equally. And so you want to keep the total to about 10 watts, but that's 5 watts for each of them. They're also right next to each other, so they'll get a little bit warmer. So definitely don't bump it up above more than 5 watts each for a total of 10 watts. And that brings us to the voltage booster right here. So we had 10 volts coming in, you get a higher voltage coming out. So this particular unit, I think you can go down to 3 volts coming in and down to 3.5 volts coming out. But whatever is coming in, you can turn the trim pot to adjust the output voltage. And the bigger the difference though, the more current it needs to come in to convert it to voltage out. So there are still limitations, but ultimately you can take a low voltage in and a high voltage out up to I think 35 volts, might be 30, but in any case a lot higher than what's coming in as possible, but you won't get a lot of current out. Hopefully that makes sense. But in case you adjust the voltage with that, you can just apply power to it. These power banks though seem to, one of them at least, seems to shut off if you're not providing much current. And so in any case, I adjusted this with one of the power banks, then I connected them in series and basically plugged it all in when I had the solar generator. So in any case, there's the output. Those are ferrule connectors. These are 16 gauge wires, and the 16 gauge ferrule seems to be as large as what will go in there. You could use larger wires. You just have to put the bare wire in there. It's a stranded wire, but that's fine too. It'll close down and hold stranded wire fairly well, but ferrules are better. And then the other end, we got the barrel plug, as I said before. So again, these resistors get extremely hot. They're cooled down now, but it's best not to touch them more than you have to. Definitely don't touch them if they're being powered. And you just plug that in there to connect the two together. And then we have the USB power banks there. So hopefully it made sense when I was showing it at the beginning there. I almost knocked them over. But we have the negative of one connected to the positive of the other. And we got to be careful both that these two don't touch each other, because that's a direct connection. Put them in series now because we got the other end of them two connected together. And we don't want to touch like this red alligator clip to the same black alligator clip that it shares right there. So there we go. Hopefully that's a good connection right there. It's a little hard to tell until you actually plug it up to see. But there you can see we got the power on, and it's already set to 17.3 volts. It keeps going back to the voltage that you set it. So like if we don't power, in this case the power generator, right now the output is just floating. I think probably the black power bank is going to shut off after a while when it doesn't have to provide much current. And I think that was just me bumping it that made us lose a connection. But in any case, it's kind of finicky, but as you could see, we did get to actually charge the solar generator a bit at 10 watts of power. And now for those of you that stuck around, this is a really long video, so thanks for that. Right here we have the equivalent of 5 ohms of resistance. If I was going to actually make this a practical circuit, I think I could actually get rid of the voltage booster and just use 3 of the USB power banks for 15 volts. And I'll explain why. So we had 4.2 volts I measured with the multimeter across these 2 resistors to get the amount of current that we had. That makes sense. The power bank needs 13 volts basically before it starts conducting. And so it's going to hold about 13 volts even as current goes up. That makes sense. The rest of the voltage will go across these 2 resistors. And ultimately these were limiting current, so the power banks didn't think there was a short circuit and shut off. They didn't limit current to 2 amps on their own. They shut off. So in any case, we had the voltage built up across here to limit current below 2 amps. And it worked. We saw we could charge it. But if I took these 2 resistors, added 2 more in parallel, so 4 in parallel, to get the same current through here, you could cut it in half. So instead of 4.2 volts across here, you could have 2.1 volts across here. So you got 13 from the power bank, and then if you add 2.1 volts across 4 parallel resistors here to get the exact same amount of current that we had before, then we would only need about 15 volts total to power that. So we could use just 3 power banks in series for 5, 10, 15 volts. We could get rid of the voltage booster, put that across here directly. We wouldn't have to deal with the losses of the voltage booster anymore. And ultimately we'd have less resistance here, so we'd have less waste heat. So less current would be flowing through each individual resistor, but you'd have the same total amount of current, ultimately less voltage needed to pump current through more equal value resistors. You would have energy savings. So that's actually, I'll probably do it in a future video, that's how I would actually wire this up now that I've done this testing and stuff and thought it through. So in any case, hope you enjoyed.